Okay, hello everyone. Today in this video we will be stretching, compressing, and reflecting quadratic relations. So let's begin with y equals x squared. And let's analyze that for a domain between -2 to +2. So let's start. Let x equal -2, y equals -2 squared equals 4. Let's begin a table of values. At -2, the y value is 4. Then when x equals -1, the y value will equal +1. When x equals 0, the y value will also equal 0. When x equals 1, y equals 1 squared. And when x equals 2, y equals 2 squared. So let's add that to our table of values. And then let's analyze what's happening here for the parent quadratic relation of y equals x squared. So you could see from the table that when we're on the left, the y value's up at 4, and as we move to the right, the y value drops to 1, then it drops to 0, then it goes back up to 1, and it goes back up to 4. So we can see that 0, 0 is our turning point. So thus, that's our vertex. So we've found our vertex. So let's do a little sketch here. And -2, -1, 0, 1, and 2. And then let's go 1, 2, 3, 4. And at -2, we're up at 4. At -1, we're up at 1. At 0, the y value is 0. And then 1, 1. And 2, 4. So you can see the parabola is opening up. Then if we analyze the shape, you can see that as we go left 1, the parabola opens up 1. And if we move right 1 from the vertex, the parabola also opens up 1 unit. So this shape can be characterized as the first step from the vertex, which when you go left or right from the vertex, the parabola opens up 1 unit. And if we consider the equation y equals x squared, this is in the form of y equals ax squared, which is standard form. And in this case, the coefficient a is +1, and you can see that the first step is up 1. So vertically positive means up. And how many units up is it moving? 1 unit up when you go left and right of the vertex. So in this case, the parent quadratic relation y equals x squared is not showing any stretches or compressions or reflections. Okay, next, let's change the a value. So let's go with y equals 3x squared, and let's consider the domain left and right of the vertex. So when x equals -1, it will be y equals 3 brackets -1 squared, which is 3 times 1, which is 3. When x equals 0, y will equal 3 times 0 squared, which is 3 times 0, which is 0. And when x is 1, it'll equal, y will equal 3 brackets 1 squared, which equals 3 times 1, which is 3. So if we put this into a table, at -1, the parabola is up at 3. At 0, the parabola height is 0. And at 1, it goes back up to 3. So you can see our vertex hasn't changed from the parent. It's 0, 0. And so the parent is still 0, 0. But when x is -1, we're up at a value of 3. And when x is +1, we're up at a value of 3. So you can see the parabola has changed its shape. When you move left 1 or right 1 of the vertex, we're now going up 3. So just like we discussed before, the a value determines the first step. So in this case, a is +3. So the first step, left or right of the vertex, will be up 3 units. So the parabola opens up 3 units because the a value is 3. And when you look at the picture, you can see it's been stretched upwards by 3 units from the vertex. Okay, next, let's consider when a is negative, and let's see what happens. So example 3, let's say y equals -2x, and based on the pattern, a equals -2, which means the parabola will open down, and on the first step will be down 2 units. So visually, we have our vertex at 0, 0, and if we go left 1, right 1, the parabola is going to open down 2 units. So it'll look like this. Let's check the table. And again, let's analyze the domain from -1 to 1. So when x equals -1, y will equal -2 times -1 squared, -2 times 1, which is -2. And that's that point right there. When x equals 0, y equals -2 times 0 squared, which is -2 times 0, which is 0. And that is this point. And when x equals 1, y will equal -2 times 1 squared, which is -2 times 1, which is -2. And that is our point on the right. And let's also place on here y equals x squared. So we have to go up 1 unit. And recall it's -1, 1, 0, 0, 1, 1. And there's our parent, y equals x squared. The blue one is y equals -2x squared. And you can see the parent had gone left 1, up 1, right 1, up 1, because the first step is +1 for the parent. But for this one, in blue, a is -2. So we're going down 2 units. So not only was it reflected because a is negative, but it's also stretched because a is greater than 1. So let's summarize these patterns that we've seen in these 3 examples. So for the form y equals ax squared, if a is greater than 1, the parabola opens up and is stretched by whatever the a value is. If a is between 1 and 0 and it's still positive, the parabola will still open up, so it opens up, but because it's a decimal, it's between 0 and 1, it will be compressed. You know, for example, if a equals 0.5, the parabola opens up, and the first step is up 0.5. So it just got compressed because it should have been up 1 if there was no transformations applied. And finally, if A is negative, so if A is negative, these same patterns apply, and in addition, it just became vertically reflected. So we could have a stretched parabola if A is greater than 1. We could have a compressed parabola if A is between 0 and 1. And if A is negative, then the parabola is reflected. So back to the parent. Negative 1, 1, 0, 0, 1, 1. These are key points to memorize for the parent quadratic when A is 1. These should be memorized. And then depending how A changes, we could have a stretch, for example, of 2. And that will be y equals 2x squared. We could have a reflection, and let's say it's 0.5, so negative 0.5. So that would be y equals negative 0.5x squared. So the negative means it's reflected, the 0.5 means it's compressed. And let's do a reflected stretch. So let's say we go down to negative 3. So we go left one, right one of the vertex. So now the negative is the reflection, the 3 is the stretch, x squared. So that summarizes this video on stretches, compressions, or reflections in the form of y equals ax squared. Y equals ax squared. And what happens to quadratics based on the a value changing? Could be a stretch, compression, or a reflection. Thank you for watching today's video. Hope you enjoyed it. Please subscribe to the channel for more videos in the area of mathematics. Leave a comment for videos that you'd like to see, and have a great day. You are awesome.